Aloha, this is Richard Halverson, ITS 128, and in this video I'm going to tackle project 8.5. So let's take a look at it. This is it. It's a column sorting problem. It looks very similar to the previous problem, except for where instead of summing up columns, we're sorting them. And in fact, we're sorting all the columns. Instead of summing up all the columns, we're sorting all the columns. Implement a function to sort columns in a two-dimensional list. The new list is returned and the original list is still intact. That just means we have to make a copy of the list or the matrix. Once we get it in, we're going to make a copy of it, and then we'll sort those columns and return that new matrix. So we're supposed to write a test program where the user enters a 3x3 matrix and displays a new column sorted matrix. And the matrix is entered exactly the way it was in the previous, in project 8.4, so we're going to start with that code, I think. Enter a 3x3 matrix row by row, and then it displays out the column sorted list. And so to see how this works, we see the first column is 0.15, 0.55, 0.30. So if we sort that, we should get 0.15 first, 0.30 second, and 0.55 third, and we do 0.15 first, 0.3 second, and 0.55 third. The second column is 0.875, 0.005, 0.12, and when we sort that, we should see this one first, this one second, and this one third, and we do. This one's first, second, and third. And for the third column, it's 0.375, 0.225, and 0.4. So we should see the 0.225 first, the 0.375 second, and the 0.4 third, just like we see here. All right, so I'm going to pop up my previous Markov matrix, and let me copy this, copy all this, and place it here. And I don't really need this. So this is what we're going to make. And these are the matrices. There's one here. I'm going to squeeze this up because I'm going to input them the same way. Okay, let's see. So I'm going to, this def sort columns is going to be similar to this. Let's see. So we're going to start out by declaring a matrix. We're going to read in, enter a 3x3 matrix row by row. That's what this says. This inputs the matrix. So we've got a matrix here that's all loaded up. And then we're just going to, I guess, we're going to, let's declare another matrix here. And we're going to say that matrix 2 is equal to this program, this sort columns thing here. Equal to sort columns matrix. Just plain old matrix. So this is what we read in. Full-blown matrix here. Let's write it out to make sure we got that. And then we're going to sort it. And we're going to print that out here. And I will leave you to make it look nice like this. You're going to make it look nice like this. Let's see what... All right, so sum columns, sort columns. Okay, so we've got this matrix coming in. And then we're going to loop column by column. I don't need this. Let's see. So I think I'm gonna write off. Okay, so this function has got to take in a matrix and return a different matrix. It cannot mess with this matrix, this M matrix that's coming in. It's got to create a new matrix and return a new matrix without messing with this matrix. So I think I'm just gonna declare a new matrix here. Declare a new matrix, and I'm just gonna set M2 equal to M, and I'm just gonna mess with that M2 from now on. Let's see. I don't need to do this. I can just loop through all of the columns because I got to loop through all the columns anyway. So I'm going to do for C in range of this. In range of that. Except for I'm going to do, well, it doesn't matter if I do one or two, they're the same. This is just a range. For each column, I want M2 to equal sort column M2, that particular column. And then when I'm all done with all that, I want to return M2. This thing has got to sort the columns instead of summing the columns. So I'm going to call this sort. And this, I got to sort the columns. Okay, how do I sort the columns? Various ways I could do that. I'm going to sort the columns this way. Let's say I've got a column here, 1, 0. I'm just going to say 2, 3, 1. I have a column here called 2, 3, 1. The first thing, so I'm going to do it by exchanging. I know a little bit about sorting, and so I know that if I compare these two and I put the smaller one on top, that's going to end up looking like 2. Let's see. Let's do this. Okay, so I've got this 2, 3, 1, and then I'm going to look at the first two here, and I'm going to make sure the smaller one is on top. So that's still going to be 2, 3, 1. And then I'm going to look at the second two, and I'm going to make sure the smaller one's on top, and that's going to end up being 2, 1, 3. And then I'm going to look at the first two again, and I'm going to put the smaller one on top. So that will end up being 1, 2, 3. You see? So the first time I look at and let's do a different example. Let's do 3, 2, 1. Okay, so I look at the first two, and I put the smaller one on top. So I'm going to exchange them. I'm going to see that the second one is smaller than the first one, so I'm going to exchange them. If I exchange them, I end up with 2, 3, 1. Okay, so I've looked at the first two, and I've exchanged them, and now it looks like this. Now I'm going to look at the second two, which is these two, and I'm going to exchange them because I want to put the smaller one on top. So that's going to equal to 2, 1, 3, because I looked at these two and I put the smaller one on top, and now it's going to look like this. And then I'm going to go back and look at the first two again, and I'm going to do the same thing I did before. The first two, I have to exchange them again, and I end up with 1, 2, 3. Okay, so this is the worst case sort. This is the worst case of the order, and I'm going to start out by looking at the first two, index 0 and index 1, and if they're out of order, I'm going to exchange them. which results in this. And then I'm going to look at the next two, and if they're out of order, I'm going to exchange them, and then I end up with this. And then I'm going to go back to the first two again, and I'm going to see if they're out of order, and if they are, I'm going to exchange them. So that's all I have to do. I look at the first two, exchange them if necessary. Then I look at the second two, exchange them if necessary. And then I go back and look at the first two again and exchange them if necessary. And when it's all done, it should be sorted. So to do that, I'm just going to do this manually. Okay, so I'm going to say, I'm going to be returning M. So I'm going to say if the first row, and I'm just going to do column index, all right? Yeah, so if the first column, I'm going to make this shorter. I'm going to call this I for index. If, actually, I might as well call it C for column. So if row 0 of this column is greater than row 1 of this column, then I need to exchange them. How do I exchange them? I can use this fancy Python assignment by going M0C, comma, M1C is equal to M1C, comma, M0C. You see? So M0C1C equals M1C0C. So this exchanges. This is the fancy Python exchange, which I've not seen in any other language, where this one is exchanged and becomes this one becomes the second one, while this one becomes the first one. So this is row 0 of the column and row 1 of the column are exchanged. So in row 1 of the column and row 0 of the column. See that? So they're just exchanged. So that takes care of this takes care of looking at the first two. So this takes care of looking at the first two. Okay. Now I got to look at the second two. If M of 1C is greater than M of 2C, then if that's true, I got to exchange them because I want 1 to be smaller than 2. So it's basically just this again, except for we're doing 1 and 2 are exchanged with 2 and 1. Oops. And 1. Okay, so that takes care of these two. And once those are exchanged or not, I need to go back and do the first one again. And I can just copy paste that. Okay, so this looks at the first row and the second row, and it exchanges them if they're out of order. This looks at the second row and the third row and exchanges them if they're out of order. And then this goes back and looks at the first row and the second row and exchanges them if they're out of order. Okay, and it does it for just one column. So what we have to do down here and sort columns is we have to go through all the columns. Column 0, column 1, column 2. And so this thing is going to call this thing 3 times because there's 3 columns. 3 times. And this thing is going to sort a column. It first looks at the first two to see if they need to be exchanged. If they do, they are. It then looks at the second two. It sees if they need to be exchanged, and if they do, they are. And it's possible that now the first, like in this case, the first two are exchanged, and it ends up looking like this. Then the second two are exchanged, and it ends up looking like this. And lo and behold, we got to look at the first two again because this one bubbled up. And we look at the first two again, and we exchange, and it ends up like this, sorted. Okay, this might be all we need. So let's run it. I'm going to save it and run it. Enter a 3x3 matrix row by row. And so let me just copy this. Copy and go over here and paste. 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 Ooh. Let's do this again. Copy. Copy. Paste. Enter. And let's see. Oh, I'm going to not print out this. I'm going to comment this out because that's confusing. Let's run this again. And I'm going to paste, enter. I forgot to save it. Look at this. I forgot to save it. It's red. Save. Let's try it again. Paste, enter. And this is the first row. This is the second row. And this is the third row. The first row is sorted. It should be 1.5, 3.55. Let's see, I'm sorry. 0.15, 0.3, 0.55. So instead of 0.15, 0.55, 0.30, it should be 0.15, 0.3, 0.55. And the next one is, it came in as 0.875, 0.005, 0.12, and it was sorted to 0.05, 0.005, 0.12, and 0.875. So that's sorted correctly. The third column came in as 0.375, 0.225, 0.4. So this one is first, this one is second, this one is third, and sure enough, 0.225 is first, 0.375 is second, and 0.4 is third. So what you need to do to finish this is you have to change the print statement out here. So instead of printing it out like this, it prints it out looking more like this. But this is how you do the sorting, or this is one way of doing the sorting. After you've pasted in your answer, you see that for all these, you'll see that the book offers alternative approaches to doing these problems. It's okay though, because the automatic grading, it actually just looks at the result. It looks at the result of your program to see if the result is correct. And as long as you print out the format, as long as you print the format out so it ends up looking like this, then you're in good shape. All right, so that should help you do project 8.5. And we only have one more to go, and I'll probably make that video tomorrow. Thanks for watching.